January 24, 1975. Low Earth orbit. 270 kilometers above the Pacific Ocean. A Soviet spacecraft, designated Salyut 3, drifts in the vacuum. To the world below, it is a civilian research laboratory, a place of biology experiments and peaceful cooperation. But inside the Kremlin, this station has a different name. It is codenamed Almaz, the diamond, and it is not a laboratory, it is a fortress. Ground control in Yevpatria sends a coded signal. The station's thrusters fire, rotating the entire 20-ton vessel 180 degrees. It turns its back to the direction of travel. It is aiming. The weapon mounted on the hull is an R-23M autocannon. It is a modified tailgun from a supersonic bomber, engineered to fire 23mm shells at a rate of 2,500 rounds per minute. The command is verified. The trigger is pulled. For the first and only time in human history, a kinetic projectile weapon is test-fired in the vacuum of space. The Soviet Union has just turned the cosmos into a free-fire zone. Why mount a bomber's tailgun on a scientific laboratory? Who were they expecting to see in the vacuum? They weren't looking for aliens. They were looking for the Americans. This is the story of the Almaz program. It is the story of a space bomber panic that convinced the Soviet Union the US Space Shuttle was a nuclear dive bomber. It is a deep dive into the Keldysh Calculation that drove Moscow to weaponize orbit. And it is the story of how the engineering DNA of this secret battle station didn't disappear when the Cold War ended. Because right now, the very foundation of the International Space Station is a pressurized hull that was originally designed to supply a war machine. Welcome to the edge of the impossible. This is Apex Engineering. To understand why the Soviets strapped a cannon to a spaceship, we have to go back to 1972. We have to look at the space shuttle not as an icon of exploration, but as a weapon of terror. On January 5, 1972, President Richard Nixon announced the Space Transportation System, the shuttle. To the American public, it was a space truck, a reusable vehicle designed to make space travel cheap and routine. NASA claimed it would launch once a week, but in Moscow, the math didn't add up. Soviet aerospace economists ran the numbers. They looked at the payload costs, they looked at the turnaround times, and they realized something terrifying. The shuttle made no economic sense. Based on payload volume and launch frequency, the development costs of the STS were exorbitant. The projected civilian demand for satellite launches was nowhere near high enough to justify the massive expenditure. To Soviet planners, the doctrine of mirror imaging applied. If a system is not economically viable for peace, its primary utility must be for war. The Kremlin concluded that the shuttle was a lie. The shuttle was too big, too expensive, and too complex to be a delivery van. It had to be a bomber. The man tasked with proving this theory was Mstislav Keldysh, the chief theoretician of the Soviet space program, the head of the Academy of Sciences. In 1976, he ordered the Institute of Applied Mathematics to reverse engineer the shuttle's mission profile based on its public design specs. They found a smoking gun: the wings. The shuttle had massive delta wings, much larger than needed for a simple ballistic reentry like Apollo. These wings provided a specific aerodynamic capability: cross range.
Cross range is the distance a spacecraft can glide laterally away from its orbital path during re-entry. The shuttle was designed with a cross-range capability of 2,000 kilometers, 1,100 nautical miles. A civilian satellite hauler does not need this. A scientific glider does not need this. The only mission profile that requires a 2,000-kilometer cross-range is a single-orbit polar military strike. Keldish's mathematicians realized that the U.S. Air Force had demanded this wing design. Why? To execute the polar dive. This is the scenario that kept the Soviet Defense Council awake at night. Step 1. The shuttle launches from Vandenberg Air Force Base in California. It launches south, towards the Antarctic. It circles the globe over the South Pole and approaches the Soviet Union from the bottom of the world, from the Indian Ocean. This was the key. All of the Soviet early warning radars were pointed north, watching for ICBMs coming over the Arctic. The shuttle would be approaching from their blind spot. Step 3. The dive. As the shuttle passes over Moscow, it doesn't just stay in orbit. It uses its massive wings to perform an atmospheric dip. It dives into the upper stratosphere at Mach 25. During this hypersonic dive, the shuttle opens its payload bay doors. It deploys a nuclear weapon directly over the Kremlin. The flight time from detection to impact is less than 4 minutes. The Soviet command has zero time to react. Step 4. The escape. Using the lift from its wings, the shuttle performs a skip glide maneuver. It bounces off the atmosphere like a stone skipping on a pond, regaining altitude to escape the blast zone and return to friendly territory. It was the ultimate first strike weapon. It rendered the concept of mutual assured destruction obsolete. Keldysh told the Kremlin, "Whenever their orbiter appears over our territory, we can declare this an act of aggression." But the bombing run wasn't the only threat. There was also the space snatch. Soviet analysts looked at the shuttle's cargo bay dimensions, 60 feet long, 15 feet wide. They realized these dimensions matched almost exactly the size of the Soviet Almaz and Salyut space stations. The Kremlin convinced themselves that the shuttle was a pirate ship. They envisioned a mission where the shuttle would pull up alongside a Soviet station, use the robotic arm to cut the panels, and physically capture the entire station. They would stuff the station and its crew into the cargo bay and bring it back to Earth for inspection. It sounds insane today, but in 1974, it was policy. The Soviet leadership issued a directive: "We will not be boarded. We will shoot them." To build a defense against this phantom menace, the Soviets turned to their most aggressive engineer. Not the legendary Sergei Korolev, who built rockets for science, but Vladimir Chelomey. Vladimir Chelomey was the Tony Stark of the Soviet Union. He ran Design Bureau OKB-52. He was flamboyant. He was arrogant. He drove a Mercedes in Moscow when everyone else drove Ladas. He hired Nikita Khrushchev's son just to get political cover. While Korolev wanted to go to the moon, Chelomey wanted to dominate the Earth. His masterpiece was the UR-500 rocket, the Proton, a heavy-lift beast originally designed to drop a 100-megaton nuclear bomb on America. Chelomey proposed the Almaz program. Almaz means diamond. To the world, these would be launched as Salyut stations, civilian labs, but the reality was stamped on the pressure hull. OPS, Orbital Piloted Station. The Almaz wasn't designed for comfort. It was a machine built around a single massive instrument, the Agat-1 telescope. The Agat-1 had a focal length of 6.375 meters. The station itself was only 14 meters long. To fit the telescope inside, the optical path was folded using a complex system of internal mirrors. It occupied the entire central volume of the station. This was a spy satellite with a human brain. In the 1970s, digital transmission was slow and grainy. You needed a human eye to spot the American aircraft carriers. You needed film. The cosmonauts claimed the resolution was so fine they could count the cars in the Pentagon parking lot. The Almaz was a sniper scope pointed at the Earth.
But a sniper scope needs a rifle. Chelomey knew that if the American shuttle came to snatch his station, passive defense wasn't enough. He needed firepower. He decided to arm the station. He went to the Noodleman Precision Engineering Bureau. They gave him the R-23M Kartech. This was a weapon born for speed. Originally designed for the tail turret of the Tu-22 supersonic bomber, it was a 23mm revolver cannon. Caliber, 23 millimeters. Rate of fire, theoretical max of 2,500 rounds per minute. Muzzle velocity, 850 meters per second. Ammunition, telescoped. The charge wraps around the shell to save space. Mass, the gun itself weighed only a few dozen kilograms. It was the perfect weapon for a cramped spaceship. Small, fast, and lethal. But putting a gun in zero gravity creates a physics problem that should have been impossible to solve. Newton's third law. For every action, there is an equal and opposite reaction. When you fire a gun on Earth, you feel recoil in your shoulder. Your feet are planted on the ground, and friction holds you steady. In space, you are floating. If you fire a 23mm cannon from a free-floating space station, the recoil acts like a thruster. It pushes the station backward. But worse, if the gun isn't perfectly aligned with the center of mass, the recoil creates torque. It spins the station. Firing a burst would induce a death spin. The uncommanded rotation would be violent. It would snap the fragile solar panel wings. It would slosh the fuel in the tanks, causing the station to wobble uncontrollably. It would disorient the crew to the point of incapacitation. You shoot the gun, you destroy your own ship. Chelomey's engineers found a solution that was pure apex engineering. They realized they couldn't put the gun in a turret. It had to be bolted to the frame. The station was the gun. To aim, you had to turn the whole 20-ton ship. But to handle the recoil, they invented the jet trigger. They hardwired the cannon's firing circuit directly to the station's attitude control thrusters. The exact millisecond the hammer struck the primer, the station's main thrusters, two 40-kilogram engines, fired in the opposite direction. The thrust perfectly canceled out the recoil force. It was a fly-by-wire miracle. Cooperative engagement. The gun and the engines working in perfect sync to defy Newton. The gun was installed. The station was launched. On June 25, 1974, the Almaz OPS-2 station reached orbit. The Soviets called it Salyut 3. 10 days later, the crew arrived. Commander Pavel Popovich, flight engineer Yuri Artyukhin. These weren't civilian scientists. Popovich was a legend, one of the first 6 cosmonauts, a military man. They docked their Soyuz and floated into the station.
The interior of Almaz was not like the civilian Salyut stations. Civilian stations had pastel colors, exercise bikes, and comforts for long duration. Almaz was a cockpit. It was gray, cluttered, and cramped. It smelled of ozone and machine oil. The crew lived on a war footing. They spent their days manning the massive Agat-1 telescope, tracking American warships. They used the OD-5 optical visor to hunt for targets. They tracked the Skylab. They tracked the Pentagon. But they had a problem. How do you get the spy photos back to Earth without coming home? You can't scan film in 1974. The solution was the KSI capsule. Space mail. The station had a specialized airlock with a small ejection system. The crew would load the exposed film rolls into a small re-entry capsule. They would seal it, depressurize the lock, and shoot it out. The capsule would spin stabilize, fire a retro rocket, and parachute down into the Soviet Union for recovery. But the defining feature of the mission was fear. Popovich and Artyukhin were isolated. They were constantly checking their radar for the blip that meant the shuttle was coming. They were heavily armed, not just with the gun outside. Inside, they carried Makarov pistols. They had protocols for repelling a boarding party. Imagine the scene. 2 men floating in a tin can, pistols drawn, waiting for the airlock to be breached by American astronauts. Popovich later commented on the sound of silence in the station. They were waiting for a fight that never came. Because the shuttle wasn't even built yet. The crew completed their mission. They returned to Earth. But the gun was still up there, loaded, untested. The engineers at ground control decided it was time to pull the trigger. The test was set for January 24, 1975. The station was empty. It was time to see if the jet trigger would save the ship or tear it apart.
The crew had left. Salyut 3 was alone in the void. Its mission was technically over, but the engineers at OKB-52 had one final objective. They had to know if the gun would actually work without tearing the station apart. Why did they wait until the crew was gone? Because firing a 23mm cannon inside a pressurized tin can is a bad idea. The acoustic vibration of the cannon firing would be amplified by the metallic hull. In the small, pressurized volume, the noise could rupture the eardrums of the cosmonauts. Worse, the structural shock could crack the pressure seals or shatter the delicate glass mirrors of the Agat-1 telescope. It was too risky. So, on January 24, 1975, with the station operating in autonomous mode and its propellant reserves nearly empty, ground control sent the kill command. First, orientation. The station rotated to face retrograde, backward relative to its orbital path. This wasn't just for targeting, it was for safety. If you fire a projectile forward in orbit, prograde, you add velocity to it. It enters a higher elliptical orbit. It becomes space junk, a lethal bullet that could circle the Earth for decades and eventually hit one of your own satellites.
By firing backward, retrograde, you subtract velocity. The shell drops out of orbit and burns up in the atmosphere almost immediately. It is a self-cleaning weapon test. The R-23M roared to life. 3 separate bursts, 20 rounds total. In the vacuum, there was no sound, only the violent vibration of the recoil dampeners fighting the kick. As the gun fired, the station's attitude thrusters fired simultaneously. The jet trigger worked. The 20-ton station shuddered, but it held its line. It didn't tumble. It didn't spin. Telemetry confirmed it. The shells were ejected. The station survived. The Soviet Union had successfully tested a space cannon. Hours later, Salyut 3 was commanded to deorbit. It burned up over the Pacific Ocean, taking its secret weapon to the bottom of the sea.
The gun worked, but the premise was a lie. The Space Shuttle launched in 1981. It flew 135 missions. It never bombed Moscow. It never snatched a satellite. The polar dive was a mathematical ghost story. The Keldysh Institute had scared the Kremlin into spending billions on a defense against a threat that didn't exist. The shuttle's massive cross-range capability was a military requirement, yes, but not for attack. The US Air Force demanded the cross-range capability to allow the shuttle to launch a spy satellite into a polar orbit and then return to the launch site within a single orbit if a malfunction occurred. It was an abort requirement, not an attack requirement. Paranoia is an expensive hobby, but in this case, the paranoia produced something valuable. The Almaz program was canceled in 1978. Spy satellites were cheaper. But Chelomey had built more than just the station. He had built a support ship, a heavy supply craft called the TKS. The TKS was a tank. It was designed to carry heavy equipment, soldiers, and even nuclear warheads to the Almaz stations. It had engines big enough to push the entire complex. When the Soviet Union fell, the Russian space program was broke. They needed to join the International Space Station project. They needed a module that provided massive power, propulsion, and storage, a cornerstone. They didn't have money to design a new one, so they went to the warehouse. They found the blueprints for Chelomey's war supply ship. And that brings us to today. The very first module of the International Space Station ever launched wasn't American. It was Russian. It is called Zarya, the Dawn. Look closely at Zarya. It is physically identical to the FGB, the functional cargo block of the TKS spacecraft. The propulsion system keeping the ISS in orbit, that's Almaz tech. The fuel tanks, Almaz tech. The structural hull, that is the hull of a military transport designed to resupply a space cannon. The Almaz program represents the ultimate paradox. It was a weapon born of a misunderstanding, a space fortress built to defend against a space bomber that didn't exist. Yet the engineering required to build that fortress, the ruggedness, the heavy lift capacity, proved to be exactly what was needed to build a permanent home in the stars. Today, when American astronauts float through the Zarya module to get their morning coffee, they are inside a pressurized hull that traces its direct lineage to the supply lines of the Cold War. The machine built for war became the foundation for peace. It proves that while politics may be transient, robust engineering is permanent.